must thank for giving me the opportunity to present, invite to talk in this international conference. I'm going to deliver the talk on convection of unitary nanofluids and hybrid nanofluids in enclosure on heat transfer. So first and foremost, we must understand what is the gap analysis with the sector relevance. As far as our Prime Minister concerned, our aim is to increase the target of getting 80% of CO2 emission control. So even 100% is not possible. We can reach 80% of that can be reached by before 2070. So for which we need to move with the effective use of the renewable energy, for which we need to consider the heat transfer enhancement in all heat transfer energy sectors and thermal power plant and radiation conversion energy sectors also. So therefore, this research purpose is to formulate a magnetic hybridized nanofluid to enhance the performance of the indirect type of solar heating water systems to harvest the heat energy. So first and foremost, we need to see about the SWOT analysis. The strength is we have the lab facilities.
Hello, madam. Yes, your slide is not moving.
Ma'am,
slide is not moving.
Is the SWOT analysis pages visible, ma'am?
No. First slide is there.
Wait, ma'am.
Yes, now it is changing and put on slideshow mode.
Yes, ma'am, I have changed. Is it visible now, ma'am? The second page?
It is, yes.
Gap analysis with
SWOT analysis. It is slide is showing SWOT analysis.
SWOT analysis is visible, ma'am?
Yes.
Okay, ma'am. Thank you. Shall I continue with that, ma'am?
Okay, continue.
Yeah. Yes, ma'am. So in the SWOT analysis, we need to consider the strengths, weakness, opportunities, and threat in that. The strength we have is exactly the laboratory facilities we have to prepare the hybridized nanofluids, and we can characterize them, and we can test. We can even test the magnified hybridization nanofluid. So, but we have the weakness also. The manufacture readiness level, commercialization readiness level, and even the technology readiness level is the lagging part in our sector. And meanwhile, we have the opportunities also. As far as the central and state government concerned, we have the we are being provided with a fund to control the emission of CO2, and they are encouraging us to have a thermal power plant as far as the DST project concerned. So even if we are provided with the funding, even we are provided with many funds through the DST project and government projects like that, we can't be able to continue them with a certain. We can't be able to continue with certain level because the weakness is manufacturing level, and we can't be able to make our product as the commercialization one. So
Dr. Mahalakshmi, your slides are not moving. They got stuck on the third slide, SWOT analysis. You are still on that slide?
Yes, ma'am. Yes, next slide is visible, ma'am. The novelty.
No.
SWOT analysis.
The novelty page is visible to us, ma'am.
You are still
only SWOT analysis.
On the third slide. Whichever slide you want to show, you just click novelty. Now you are novelty.
Okay.
Or Dr. Manorama, please admit the people so that they can enter in the meeting.
Yes, I am admitting, madam.
Okay. The novelty of the hybridization nanofluid is, we can see that if we consider the nanofluid alone with a base fluids means we can't be able to enhance the heat transfer. Whereas if we consider the hybridized nanofluid, we will be able to get the high heat transfer enhancement. So that is the purpose of considering the hybridized nanofluids than the unitary nanofluids. So in microprocessor, electricity generation, and even in aircraft engine cooling system, we have the ample applications in using the hybridized nanofluid. So as far as the thermal power plant applications concerned, if we consider the mixed convection inside the enclosure, we can be able to control the emissions of the nuclear wastage. So in this, we can be able to see the how the nuclear power plant sector workers are able to control the emission of the thermal wastages. They have simply immersed all the power plant wastages by applying the hybridized nanofluids. So now we are going to see the numerical analysis, for which we need to consider the configuration. So here we can be able to see the numerical configuration in which we are considering a square enclosure. This is fully filled with the nanofluids as well as the hybridized nanofluids, and we are considering the cold wall at the two vertical walls, and whereas the heat source is embedded at the lower wall, whereas the top wall is considered as a adiabatic one. So if we consider this type of configuration, we can be able to get more heat transfer. So for this configuration, first we need to form the governing equations, in which we will be having a equation of continuity, momentum equations, and energy equations. Since we are considering a two-dimensional configuration, U momentum and V momentum equations will be considered, and the corresponding boundary conditions are considered, because since we are considering a mixed convection, we need to keep the vertical walls as moving. The left side wall is concerned with the movement towards up, and whereas the left side wall is moving towards down. So accordingly, we have the boundary conditions, and since we are in the process to enhance the heat transfer, we need to consider the heat transfer coefficient, which is nothing but the Nusselt number. So average Nusselt number has to be calculated to get the required heat transfer enhancement. So for which we need to consider the Nusselt number equations. So these equations will be calculating the heat transfer analysis at both sides of the vertical side walls of the enclosure. So these are the numerical approaches. We are considering the simple algorithm.
Mahalakshmi,
Yes, ma'am.
sorry to interrupt you. You have only 4 minutes, right?
Okay, ma'am. Okay, ma'am.
Dr. Nagendra Prasad, please mute yourself.
Okay, ma'am. I'll complete. So the simple algorithm and tri-diagonal matrix algorithms are being applied on this. And since we are applying the hybridized nanofluid, we need to consider the thermophysical properties like specific heat nanofluid, thermal expansion coefficient, and thermal diffusivity, dynamic viscosity, and thermal conductivity. And these are all the thermophysical properties of the nanofluids, and we need to undergo the grid independence test, and we need to get the correlation between the already existing results with our new work also. So as far as this journal publication concerned, we have reached the highest heat transfer by considering the nanofluid, silver water nanofluid. So in which we have reached the highest heat transfer with 15 almost by considering the mixed convection heat transfer, in which we have obtained the highest heat transfer for horizontal heater with length gamma is 0.75. And in this next paper, we got the result for obtaining the highest heat transfer with again silver water nanofluid. And in this, we have done the comparative study with silver water nanofluid, copper oxide, and aluminum trioxide. So even though we did the numerical simulation for these three different nanofluids, we got the highest heat transfer by silver nanofluid combination. And in this problem of magnetohydrodynamic effect on thermal transport by silver nanofluid, in which we have applied the magnetic field effect. So whatever it may be, the thermal power plant or heat exchanger applications, we need to consider the magnetohydrodynamic effect also to have the appropriate heat transfer. So for which we are applying the magnetic field effect on this. And as far as this paper publication concerned, we did the mixed convection heat transfer analysis, and in this we have done the variation on Richardson number 0.01, 1 and 100. So for the Richardson number 100, we got the highest heat transfer rate. So this is the result of this work. And after that, we did the numerical simulation work on considering the hybridized nanofluid, in which we have considered the silver nanoparticles as well as the copper oxide nanoparticles. With this combination, we have obtained the highest heat transfer. So among all these paper publications concerned, we did get the highest heat transfer in hybridized nanofluid on comparing with the rest of the numerical analysis on heat transfer. So I am concluding that we can be able to obtain the highest heat transfer in hybridized by using the hybridized nanofluid than the unitary nanofluid. Thank you for patient